Okay, so we want to solve the first problem of the study guide. I am not going to show the exact same one. I'm going to show a similar problem. So if we had something like x, let's get closer. X, 4 over 3, and a fourth root. All right. So first step would be to change this in fractional exponent. Remember, whenever we're inside the radicand, there's always a 1 as an exponent. Therefore, we get 1/4 because my index is 4. It goes in the bottom. And the radicand goes inside. So x to the 4 over 3. Okay. Now we're going to use power of a power, which means we are going to multiply our exponents. So that is, change this to green. So that means I'm going to multiply these two. So yeah, 4 over 3 times 1/4, which is equal to 4 over 12. Same thing as 1/3. Okay, what you can do is also cancel these out, and we're left with 1/3. So this equals 2x 1/3. Okay, this means one equivalent expression. This is an equivalent expression of this. Another equivalent expression is rewriting it into a radical form with an index of 3, x to the first power. Since we don't have to put 1, this is also an equivalent expression. Okay, so this is for number 1. Okay, here's the next problem. Write two equivalent expressions of 3x to the 5th power to the 2/3. Okay, first things first, there are two ways to do this. But this is how I would do it. Okay, first write the original equation, 3x to the 5th, 2/3. Then we use, since we have two terms inside parentheses, you distribute the exponent. Okay, exponent is 2/3. Distribute it here. So we should get 2 over 3, x to the 5th, 2/3. Okay, and then we multiply our exponent. Remember, if there's no number under the denominator of a number, you put 1, and then you just multiply straight across. So we get 3 2/3 and times x 10 over 3. Okay, 10 over 3. So I showed you guys one way during class. Here's the other way to do it. You can rewrite the exponent into radicals. Okay, my indexes are 3's, so let's just write the radical into 3, and 3 squared goes inside. Let me use black for that one. 3 squared. Okay, and then the other one, 3, and then x to the 10. Oops. X to the 10. Okay, so here's one equivalent expression. Since they both have the same index, you can combine them under the same radical. So here's one solution. 3. 3 squared is the same thing as 9. And x to 10. Okay, that's one answer done. One answer done. Another way to rewrite this is, of course, we want to simplify. So to do this, separate it. So let's go back to here. 9 times cube root of x to the 10. This one, we can't do anything about it, so let's leave it alone for now. But this one, I can rewrite it into, so let's write everything down first. Since my index is 3, I want to rewrite x to the 10 with powers of 3. So x to the third, that's 3. This is 6 now. This is 9. And the last one is 10, okay, with a power of 1. So if I add all of the exponents, 3 plus 3 plus 3 is 9, plus 1 is 10. Good. Okay, and then we would cancel out the indexes, right? So that means I would have to take out 3 x's. So x cubed, and the leftover inside, which is x, right? And don't forget the cube root of 9. And now let's combine this and this because they're under the same index and under the radical. Remember, this one goes outside, x cubed, and then 9x. And that would be, these two would be your answers. Okay, if it's number 3, this one is pretty, this is just adding exponents. So first we want to rewrite our radicals. Okay, so what's my index here? My index are both 7. Good. That means I can combine these two at the end. So my indexes are 7s, and my exponents are 2 and 8. So let's first rewrite this one. My index is 7. My exponent is 2, and my radicand is, well, let's not do that. Let's just put index is 7, radicand is 5 squared. Here, my index is 7, my radicand is 5 to the 8th power. So that means I can rewrite this as 5, 2 over 7. This is 5, 8 over 7, okay? And we are multiplying. Remember, what property tells me that if we have the same base and we're multiplying, what property is that? Okay, you guys need to know what property it is, and this is the only thing that you'll need to remember, which is product of powers. Product of powers, which tells me I will add the exponents. Okay, so let's bring it down here. Now we have, so this whole thing over here is equal to 5, 2 over 7 plus 8 over 7. Okay, they have the same denominator, which means I am going to add straight across, so 5, 10 over 7. So this is an equivalent expression for this problem. Okay, so here's number 4. Same thing as number 3. Remember, what tells me, so find an equivalent expression for 13 to the 1/3 times 13 to 4 over 5. So here we are going to look at my bases. I have the same basis, 13, and I am multiplying. Now what property tells me to do that? It is product of powers. Okay, product of powers tells me I can add my exponents. Okay, so that means we get 13 1/3 plus 4 over 5. Okay, but my indexes or my denominators are not the same, so I'm going to pull it to the side and do the problem with it. So 1/3, I wanted to, so first step was to multiply my denominators. 3 times 5 equals 15. I want 1/3 to become, so I get 1/3 plus 4 over 5. I want to multiply 1/3 with 5 over 5 to get 15. I want to multiply this by 3 over 3. I get 5 plus 15, 5 over 15, plus 12 over 15, which is 17 over 15. So I'm going to replace this with the highlighted. So I get 13 to the 17 over 15, right? So this is an equivalent expression of that one, but we are not done. If you don't see your answer in the multiple choice, you want to keep going. So then we get 13. So we want to change 17 over 15 into 2 rational. So give me a number that 15 divides and that is less than 15. We should get 15 plus 2. Okay, so that becomes 13. 1. 15 divided by 15. Oh, before I do that, let's separate. So 15 over 15 times 13, 2 over 15, which is equal to just 13 because 15 divided by 15 is just 1, times 13, 2 over 15, 13, 5th root, 15th root of 13 squared, which should be 13 15th of 169. Okay? If you have any questions, let me know. Okay, so I want to simplify this. So we've already talked about distributing with radicals and rational exponents. Okay, so the way we learned this was we multiplied with radicals. Okay, so first things first, I want to change this into a radical. I want to change this into a radical. Okay, so let's work backwards here. This becomes 7 squared cube roots because my index is 3. And this first one stays the same. Plus, but I want to change 7 squared into a radical. How do I do that? Well, first of all, 7 squared, right? I want to change this into a fraction with a denominator of 3. So that means we're starting with 2 over 1. Whoops, 2 over 1. Okay, I'm going to pull this out to the side. 2 over 1. Okay, how can I make this with a denominator of 3? To do that, I would have to multiply 3 over 3, which is equal to 6 over 3. It's valid, right? 6 divided by 3 is indeed 2. So 2 over 1 becomes 7, 6 over 3. So let's put that here, 7. Oh, which is 6, 7, 6 over 3. So I'm going to rewrite this as a radical. 3, 7 to the 6th power. Okay. So now let's distribute this one here. We should get 3, 7 squared times 3, 7 to the 4, plus 3, or cube root of 7 squared, times cube root of 7 to the 6. They both have the same index, so they can go under the same radical. 3, so this becomes 7 squared times 7 to the 4, plus, again, same here, same index, cube root of 7 squared times 7 to the 6. So they have the same base, and it's a multiplication, so I'm going to add the exponents. Becomes cube root of 7 to the 6. This becomes cube root of 7 to the 8. Okay. So now let's change it into a fractional exponent. Okay, you just need to make sure that your index is in the denominator, right? Plus 7, 8 over 3. And let's keep going since 3, or I think this is fine. This should be fine. Okay, so make sure you get here. And let me see here. So once you get here, you can just make sure you know how to rewrite this. Oops. You just need to know how to rewrite from fraction to radical form. Let me know if you have any questions. So for x cubed equals 36. Okay, this might seem just like what we've been doing so far. And it really is, except you have to rewrite. So how would I get rid of my exponent? How do I get rid of my exponent? What's the opposite of exponents? The opposite of exponents are index. So you want to cube root, since my exponent is 3. You want to cube root both sides. So whatever you do on one side, you must do on the other side, because it is an equal sign. Okay, so this cancels out. I get x equals the cube root of 36. Okay, how is that possible? Okay, if I factor out 36, I get 6 and 6. 2, 3, 2, 3. That means there's no number that repeats 3 times, so this must be the answer. Okay, well, there's another way to rewrite this. So x equals, so what's the, let's write it as a, oh, not yet. So x equals this so far. What's the square root of 36? It is 6. Again, it's just dissecting. That's what I told you guys on Friday. 6 squared. Okay. So then here, from here, you just rewrite it as a fraction exponent. 6 to the 2 over 3. That's it. Okay. So let's simplify this. So this is the same thing I showed you guys on Friday. Okay, so I want to rewrite this. So first things first, let's simplify this. So here's one way to simplify it. 436 x to the 10. Obviously, 36 cannot be divided into 4 of the same number, so 36 stays the same. Oops. 36 is the same. But 10 is greater than my index. So I'm going to separate 10 so that it's less than my index. So x to the 4 times x to the 4 times x squared. Okay, 4 plus 4 is 8, plus 2 is 10. So this cancels out. That means it goes outside. Both of them goes outside. So we get x squared, 4th root of 36, x squared. So this is one answer. Okay, another answer is this one. 4th root of 36, x to the 10. You'd want to rewrite this. Remember, if it's inside my radicand, my radical symbol, you put parentheses over it and you put to the first power. So you can rewrite it as a fractional exponent to the 1/4. Okay, all of these ways you guys should know how to do. This is the one I showed you on Friday. So I distribute my exponent by power of a product, right? So this becomes 36 1/4 times x to the 10 1/4, which is the same thing as x 10 over 4. Remember, it's 10 over 4. Multiply the numerators. From here, you should get, let's dissect 36, right? 36 is the same thing as 6 squared. I want to dissect 10 over 4. It becomes, so x 10 over 4 is the same thing as x 8 over 4 plus 2 over 4, which is the same thing as 8, or x 8 over 4 times x 2 over 4, right? Which is the same as 8 divided by 4 is 2. 2 divided by 4 is 1/2. So I'm going to replace this with this. Whoops, I didn't mean just 1/2. X to the 1/2. Okay, and I'm going to replace this with this. So it becomes 6 squared to the 1/4 times x squared times x to the 1/2. Okay, so we know that this over here times 1/4 is 2 over 4, which is the same thing as 1/2. Okay, and remember, the whole number goes outside. So x goes first, and the number goes next. And then the variable. Okay. So this is another way of doing it. X squared. And this would become 6x 1/2. X squared. 6, or radical, or the square root of 6x. Okay. So just do it step by step. Try to practice this multiple times before the test. Another way of doing this as well is just keeping your 8 over 8x 8 over 4. So this is another way of doing it. Come on here. I am going to take this. So equals 6 2 over 4 times, so I'm just aligning. Okay, 6, 2, or 4. Here's another way to do it. Keep it the same, x to the 10 over 4, right? And simplify it as this is 6 to the 1/2 times, divide this by 2 on both sides. On top and bottom, we should get 5 over 2. So you would get x 5 over 2 to get the same denominator, right? So then this would become 6, the square root of 6 times x to the 5th power. Okay, this would be the third choice. So here's the first choice. Come on, scroll up. The first choice is this. The second choice, come on. Second choice is this, and the third choice is this. Okay, so you guys need to know your index. Your index.